Welcome to my lecture on Chapter 2, Understanding Structures. Before I begin, there are some author embedded videos in this PowerPoint. To make it manageable, I'm going to skip those because I have those posted in Blackboard. So when you get to the point where you see a video on the screen, or if you're reading the book and you see the little video camera, either stop the video or stop reading and go into Blackboard. And I think it's under student resource. I showed it everyone in class. They're there. Just select the one you want and watch it. And just make this video a little bit more manageable because it's going to get kind of long if I do that. Okay, so what is structure? Before we had what's called structured programming, people would write code just any old way. Like you may have a go-to statement. You'd have, x equals y plus 3, and then a decision if x is greater than 50, then go to line 2051. And so you had all these jumping around issues and different ways in and different ways out, and it was just about impossible to get it working without logic errors being just embedded in it. It's just the nature of doing things that way. So they had to come up with something called structured programming. And what that means is essentially there's structured programming consists of three elements. Sequence, one instruction after another. You do A, you do B, you do C until you get to the end of the sequence. Selection, also known as decisions, like if statements. And then the third one is looping. It's also called repetition. It's also called iteration. You'll see it in different contexts like that. And you can diagram any program using one or all of, two or three of those. So it's very powerful, and it also reduces the inherent problem with logic errors that you get from spaghetti code, unstructured programs. So let's continue on here. Okay, so here's the first one, and then what it looks like in a flowchart system. It's just, these are processes, right? The rectangle. So you do process A, process B, process C. So they just do this one, this one, this one in that order. You can put any number of tasks in that sequence, but there's no ability to branch off or skip tasks based on certain conditions. So that's a stepwise or a step-by-step execution until the sequence ends. Next, we have the selection structure. Now there are two types of these. There's the single alternative if and the dual alternative if. These are also known as if-then-elses. If some condition is true, which is the diamond, that's a condition, it's either going to return true or false. It's a Boolean value, or yes or no, or on, off, whatever you want to call it. If it's true or if it's yes, you come over here and do this process. If it's false, you come over here and do this process. But notice there's only one way in here, and you're only going to execute one or the other. You can't do them both. And then they join together, and there's one way out. That's another key that you'll need to remember and make a little note of. Structured sequences or structured bits of code snippets, have one way in and one way out. The loop is a little bit different, but it's still essentially one way in and one way out. Okay. Now this is what we call a dual alternative if, because you do something if it's true or yes, and alternately you do something if it's no or false. Either way, you're going to do something. That's not always needed. Sometimes you'll just do something if it's false, or sometimes you'll just do something if it's true. It just depends on the conditions that you're working in, what you're trying to do. Here's an example of a dual alternative if. If the hours worked are more than 40, then you have to calculate regular pay and add overtime pay to it. So there's a couple calculations. Otherwise, if it's not more than 40, it must be 40 or less, right? Else, calculate regular pay. That's a dual alternative if. You have the true side and you have the false side. You do something on the true side, you also do something on the false side. That's a dual alternative selection. Single alternatives. Here's an example. You don't always need a dual alternative. If the employee belongs to a dental plan, then deduct $40 from the employee gross pay. Well, if the employee doesn't belong to the dental plan, what should you do? Nothing. There's nothing to do. There's nothing to deduct. That's an example of a single alternative if. It really just depends on what you're doing, what kind of problem you're trying to solve, and how you set it up. And you can also add these things to each other. You can have if statements that have sequence, process A, B, and C. Then you can have that inside of a loop, and just any old way you want to put them together, okay, as you'll see as we go along. Okay, here's the loop structure. Now notice it looks like there are two ways into this decision, and really what a loop is, it's simply a combination of decision and sequence added together. The decision determines whether this is going to continue to loop or whether it's just going to blow out of it. All right. Like I talked about in class the other night, if you had to do something 1,000 times and you didn't have a loop set up, then you would have to write in sequence 1,000 sets of commands, which is untenable. This way, you could set a counter up in here and decide when I get to 1,000, I'm done, out I go. Okay, so you really have just a couple lines of code and you're done. It continues to loop until some condition is false. Okay, in this case, or no. And you can combine these, like I said earlier, in just any old way you need to. There's no set way of doing it. You just do what you need to do in order to solve a problem and reach a certain outcome. End if, usually that's pseudocode, end while for loops, end if for decisions. All it does is just shows you the block of what it is you're doing. So, and when we get into the in-class project, you'll see how that works. Okay, so here is a little pseudocode, and the author does this a lot. This is your pseudocode, and it shows you how the associated flowchart will look. So you got step A, that's sequence, and then you do step B. Then here's your decision or selection. Is condition C true? If it's yes, then you come over here and do step D and go out. If it's no, you come over here and do step E and then out. Now, is this a single or a dual alternative if? Well, if you have something to do on both sides of it, on the true and false side, the yes and no side, then it is a dual alternative because you got two different things you can do. Here's your loop. After you come out of this if decision here, you come down here. Is condition F true? Now, we don't really know what these conditions are or steps are. It doesn't matter. It's just a way of looking at things. So is condition F true? If it is, then here's a sequence. You come over here and you do step G. You could have 4 or 5 steps in there. Come back, ask it again, come back, ask it again, ask it again, ask it again until this condition is false or no. If it never switches, if it never goes from true to false or yes to no, then you have what's called an infinite loop, which we'll talk about later. So here's an example of an if structure containing sequence. And this is what we call a single alternative if. There's nothing to do on the no side. There's no processes in here. It's just on the yes side or the true side. So if condition H is true, come down here and do step J, step K, step L, and out. Now notice how these are sort of bound together with a horizontal line and one arrow coming out of it and one arrow coming into it. That means it's structured, because even though there's a no over here in the flowchart, you have to have some way to get out. You can't have 2 ways out. Okay, remember that. Structured programming necessitates one way in and one way out. Now, sometimes it's bigger structured program than spaghetti unstructured programs, spaghetti code, because by nature you're going to have some repetition in here. And I don't mean looping, I just mean duplicate code. Okay, and you'll see that in a moment. All right, here we go. Here's your outermost structure is an if, a decision. If condition H is true, then do step J. There's step J. So it flows this way. And here's a while loop. So you're going to do this loop while some condition is true. Now, on the other hand, you can also loop while condition is false. It just depends on what you're doing. Okay. Most of the time in these books, you'll see it when you're looping while the condition is true. You can flip that logic around. It doesn't really matter, but so we go in here, test condition M. If it's true, then you come over here and you do step in, come back, and reevaluate it. In other words, your loop always comes back to the evaluation. You seldom have, and it's not good practice to have a lot of different things above this. Okay, that's considered not structured. So your loop has to go right to this decision again, just like this. All right, once this is false or no, you do step L and out you go. If this condition is false or no, you just come down here and skip all that and just go on to the next piece of code. Now these are not complete programs. They don't have a start and a stop. They're just little snippets of code and flowcharts and pseudocode. Notice how you indent here, and this is something I'm sure I will talk about or have talked about in class. Every time you have a structure, you indent, and that's just for readability. You just don't want everything lined up like this. So your if is your outermost structure here, and then you have a sequence, and then you have a loop, and all that's at one level. See that? And then inside the while, you have step in, so it's tabbed over. And you can see how these nested things can get rather deep. Here's a condition. This is an if statement. If condition H is false, then you go here and out you go. There's nothing to do. This is a single alternative if with more ifs and loops inside of it. Okay, so let's say that condition H is yes. You do sequence, step J, then you fall down into here, and this is a decision. If it's no, you do step L, and then out you go. If it's true, however, then you come down here and you have a dual alternative if, right? So this is actually a decision that drives a loop, and you can see that right here. Okay, so condition M is true or yes. Come down here and test condition O. Remember, these conditions test either true or false. They're Boolean values. They can't be anything other than true and false, or yes and no, or on and off. It just depends on the book and how you're looking at it. Condition O is true, yes. Then come down here and do step P. Come down here and trace this arrow back, and that's a loop. It loops right back to the condition that drives the loop. And you can see here that it is a while loop. So we're going to do this loop and everything in it while condition M is true. So we have a dual alternative if nested inside of a while loop. And inside the dual alternative if, we have sequence. You do this and you go out, or you do this and you go out. And that's basically how that works. So in the book, they tend to show you both pseudocode and the flowchart. I like to do the pseudocode first. That's just my personal preference, because the flowchart is just a logical flow with pseudocode stuck in there, basically. Now, they've basically showed you already how to combine these, and you'll get plenty of practice with that. You can nest anything within anything else. Again, they're just showing you the three parts of structured programming, the three structures: sequence, selection, and looping. I'm going to skip this. This is understanding structure. That's in Blackboard. You can go to that. Okay. Priming input. This is something from holdover from long ago. EOF means end of file. So if I have a notepad document open and I've got 3 or 4 lines in there, and then I hit enter and save it and close it, it puts an end of file marker in there, which you can only see if you look at it in a hex viewer or something. It's there though. Word documents do the same thing. So what this is saying is, grab some input, and it's going to be from a file because it's EOF. That's not important. You don't have to get torqued out over that. Just kind of follow me here. That's not my point. I wish they hadn't used this example because it's kind of confusing. Nonetheless, you get input. Parallelogram is for input and output, right, in a flowchart. Input, original number, that's the variable into which the input will be stored. If you look up here, you can see the declarations section. There are 2 variables declared. Now, what's wrong with this? They didn't initialize them. I require you to do that regardless of what the book says, because that's incorrect. They do it some places they don't. What data type are these? Well, in CIS150, we only look at 2. It's either numeric or it's string. Num is short for number, so that means both of these are numeric. So we're getting numeric input from somewhere. Now, because this is a logical design, we don't really care where it's coming from or what format it's in. We don't care. That's not the point of this. That's the physical design. Right now, we're just showing how to solve a problem. All right, so you get that input. It's stored in the original number. Is it EOF? If it is, you've read all the data out of the file, and you stop the program. So it loads in the memory here with start and unloads at stop. How can it do that? You say, well, there may be an empty file. And if it's an empty file, EOF will be true, and out you'll go. If it's not EOF, then there's a value in there. And we're going to do calculated answer, assignment, original number times 2. This basically doubles the number. Output, calculated answer, and you come back here. Now, it just keeps going and going. So it works. But the logic is not structured because this has to be right at the top of the decision. It can't be above some other group of sequence and structures up here. So that's what's wrong with this. Okay, now the priming read. This is what's called a priming read. The logic is structured because now this loop is coming right back to the decision, but there's a logical error in that it's not going to do what was intended, what the other program did. You get your input, original number, same thing as we did before. If you go back, you'll see that. See, all they did was move it from up here down to there. Is EOF? If it's not, there's a number, calculated answer, output calculated answer. So think about this. What's wrong with this? Okay. Let's say that that we have three values in a database or a data file, notepad, 3, 6, and 9. Well, when you open it up, it's going to get the 3 out first. It just goes horizontally up and down the file, or down the file. So input, original number, stores a value of 3. Is 3 equal to EOF? Nope, it's not. So that's a valid number. Come down here, calculated answer, which is where we're going to put the doubled number, is 3 times 2 is 6. And so that's what's stored in calculated answer. Now we output the value stored in calculated answer. So what do we get? 6. Come down here. Original number is going to be 3 till the end of time. So you have an infinite loop that will never end because it's not getting the next number in the file. It only got 1. All right, that's what they mean. The logic is structured, but the outcome, it only gets 1 input, and it just keeps giving you 6, 6, 6, 6, 6, and then on. How do you fix that? Well, this is called the priming read. It's done before the value is tested in the loop when you're reading from a file. You can watch that. All right, then you have what's called a subsequent read. This will fix the problem, and it is also structured. It doesn't have any logic errors. That's your priming read. You do this before you go into the loop. So you grab that, do this. Is it a number? Let's say it's 3. Yes, it's 3. So now we store 6, and we output 6, and we get the next number, which is 6. Remember we said it was 3, 6, and 9. Is 6 equal to EOF? No, it's a valid number, so you calculate this. So now calculated answer is 6 times 2 is 12. You output 12, and you get the next number. So 9 is the new number. Is that, see, there's your subsequent read. Is 9 EOF? Nope. So 18, output 18, grab the next number. Well, we're at the end of the file because we said there were 3 numbers in this file, 3, 6, and 9. We've done 3 reads. This is our final read because it's going to get, guess what, EOF. And if it's EOF, you stop the program, you're done. All right, so priming read, subsequent read. That's what that's doing. Why do we use structure? Well, it's been done for 60 years probably. And it's morphed its way into the object-oriented world, but it's still valid and still usable, and we still do it. It's just moved into classes and objects and things. Clarity, professionalism, efficiency, maintenance, modularity, which means reusing code. All this amounts to money. The clearer it is, the less time it takes another developer to see what you've done. Same thing with professionalism. Efficiency, it just means all this saves money. Money's what really matters in all of this. Just be aware of it for testing purposes. Okay, how do you structure unstructured code? Well, first you have to see where it's unstructured, okay? So remember I said that for a program to be structured, you can only have 1 entry and 1 exit. So what we can do is take these pieces and just look at it in pieces, right? We'll get G, look at G, and then we'll look at this, and we'll look at this, and look at that, and look at this, and then we'll see where it's unstructured. And it is unstructured. How many ways into G are there? 1. So that's in 1 out. 1 entry, 1 exit. G is structured. And I'm going to show, there's some more slides on this. I just want to talk about it while we're in here. This is a decision. It is a dual alternative decision. Is H true? If yes, I. If I is true, you do K and then you're out. If H is false, you just do J and you're out. However, if H is true and I is false, you do J. How many ways into J, folks? Whoops. 2. Here and here. That is unstructured. Well, how do you fix that? Remember I said that often structured code is bigger than unstructured code? That's fine, which means you will duplicate certain parts of the program. So if I on the fault side has to go into J, and H on the fault side has to go into J, they both can't go into the same J. How do you fix it? You have another J for I to go into, and you tie it back here. So you duplicate J. There's some steps we just went through. See this? They duplicated J. That's all they did. Now all this would be tied together with one way out right here. You have a horizontal line and another. They just didn't bother to do that. And another arrow coming out. Because there's no way that you're going to have two ways out of one of these. It's either one or the other. It's either true or false, yes or no. So it doesn't matter how you tie them off as long as you do that. There can only be one exit point. And there is the whole thing. You see how they did that? Just tied it off that way. Now, this is rather voluminous, for lack of a better word. This is a dog washing flow chart, but it is structured. I don't know how many of you have tried to wash a dog that doesn't want to be washed. But before we get into this, I want you to look and see that catch dog, and this little loop is structured right. It's reused right here. It's reused right here. Okay, that's okay. In order to be structured, you may have to duplicate parts of it. Probably will. So you start the program, you catch the dog. Does the dog run away? If the dog runs away, you catch it again until it doesn't run away, until you grab a hold of its collar or something, right? Then once the dog doesn't run away, you turn on the water. Well, guess what? When he sees the water, he's likely to panic and try to run away again. So you have to test that again. Does the dog run away? Yes. Turn off the water now because we have the water on. So that you've added a little something in here that you didn't have here, but it's basically the same thing. Turn the water off, catch the dog. Does the dog run away? Yes, catch the dog. See this? It's duplicated. It's perfectly fine to do that as long as it achieves the goal. Does the dog run away? No, you turn the water back on. Now, does the dog run away when the water's back on? If yes, you go through here, turn the water off, catch the dog, blah, blah, blah. So it just repeats until the dog doesn't run away. Maybe you tie it to a tree or something. And when the dog does not run away, you get the dog wet and apply shampoo. Now, when you got the shampoo on the dog, they usually don't like that either. Does the dog run away? If yes, you go back. Look at this. This is all duplicated right here. See that? Does he run away? Yes. Turn off the water, catch the dog, blah, blah, blah. Does the dog run away? No. Rinse the dog, and you're done. That's it. So you can see that it's okay to repeat pieces of code in order to structure it. And I'm going to let you watch the video. That's the end of my lecture on chapter 2, and we'll talk about projects and in class and so forth. So I'll probably do the lectures as videos from now on. Just flip the traditional way it's done because I don't have 2 days, I only have one to cover each chapter. This way I can make the video, cover the lecture, you can watch it, and then we can do stuff together in class, like in class, and I can get you started on projects and things of that nature. All right, enjoy. I'll see you at the next one.